Hello, everyone. I'm Kristina, and I'm going to give you a little bit of today's and yesterday's weather. So, Dominik and me, we are from Zagreb in Croatia, the central city. The weather is quite nice. In Zagreb, it's mostly sunny, which we quite enjoy since this May has been quite weatherly challenged with a bit fresher weather than we are used to. So please, can you put a sign somewhere where you're from? Okay, so we have some people who are not from Europe as well, if I understood well. Okay, we will not be looking only at Europe. We will also have a peek at some other parts of the world. So let's take a look at today's weather at the Airmass RGB. So if you'd please be so kind and put a line where you see a border between warm and cold air mass. So for those who are not maybe that familiar with the Airmass RGB, the colder the air mass is, the color goes more to the blue and purple, and the warmer air mass is then more in greenish tones. So if we would put a line, we would maybe put it like this. Okay, you cannot see it that well. Let me choose another color. Okay, yes, good, Carlos. Thank you. Yes, so the air mass is really a really good way to get a first impression. Okay, and now let's have a look at the systems. We have here a frontal system, and then we have here warm front and a cold front, and then we have here one frontal system. It's like cold front, then we have occlusion, and then here is a bit of warm front here. So the next question is, can you tell me, somebody put already here a sign when I asked cold and warm air. Could you tell me what is this? Why is this so pronounced kind of reddish orangish color? Yes, stratospheric air intrusion. Very good, thank you. So let's continue then. So if we take a look at what's happening in the upper levels, why this happened, we can see a really nice trough here with an upper level low. Here we have a jet stream that can really easily be seen as well if we do a cross section. So let's have a look. So we'll make a cross section here. Let me just erase this so it doesn't bother us. Okay. So we have a cross section, and then we can see here on the right side to the east, you can see in the upper levels the jet stream with its jet core. And now let's have a look at the PV anomaly. You can really nicely see how it spreads all the way towards the troposphere from the stratosphere. And what is really indication of the stratospheric intrusion is actually the dryness of the air, and that's why the color is so brownish, reddish here on the RGB image. Okay, so the systems were a bit different yesterday. If we compare it, so the upper one is from today and the lower one is from yesterday. The trough was a bit more towards Croatia and it was more straight up. It wasn't so leaned towards the west. And you can see that the frontal systems, the one is a bit to the west, all the way from Iceland towards Croatia and the Alps, and the other system that it's still here today is over the eastern part of Europe. So Croatia yesterday looked really nicely in the morning. It was sunny, only patches of here and there. There was fog since we had some rain in the days ahead, and since there was no wind in the morning, we had some patches of fog. But as the day progressed, you can really nicely see how on the eastern part of Croatia, where we have the, let's say, front part of the PV anomaly, you have rising of the air and small convective cells developing because there isn't too much forcing. You can really see that it's nice and small cumulus, not developing too much. While on the western part of Croatia, where we have subsiding air, we have no cloudiness yet. But as the day progressed and the warm front was coming nearer to us, the air was going over the Alps from northwest, and you can see how nicely the waves from the mountain ranges over Slovenia caused the development of mountain waves. So another thing that caught my eye yesterday, since I was in the shift, so I had a chance to look at all the images. Can you guess what caught my eye early in the morning as the sun was rising? Okay, yeah, there were really some high clouds here on north of the Dead Sea. But what I meant is here, if you compare the color of the Adriatic Sea to the color of the Mediterranean, you can see how it's brownish. It's because there is a lot of dust in the atmosphere. So I went to have a look how that happened. It looked really interesting, and there was really a lot of it. So I wanted to know how it happened. So this is from May 24th, the loop, till today morning. And here is a frontal system going over Sahara. So you will see as convection develops how it will produce the lifting of the dust. Especially nicely it's seen during the day, and then as the night falls it's less well seen. And then another wave is then here all the way to the east, and then on the same front here a day later. See, so it's really nicely seen how the movement of the front actually caused such a high amount of dust in the air. Okay, so another thing that caught my eye was actually this area here. It's actually almost the same shape as the desert at this point. Let me show you. So here is that desert, and you can see the shape is exactly the same. So I was really curious how come this shape, and it's actually the season when you have the winds there. It's just starting at the end of May. So it's a 120-day wind. It's a seasonal wind that starts at the end of May and lasts until September. It happens like you have really here a valley that's between big mountain ranges, and the wind starts seeping in, so it moves the dust. And since the wind started, it gave such a nice shape. However, since some convection started in the following days, the windstorms got worse and worse. And then by the end of yesterday, the dust spread almost over all Pakistan. And as you can see, it's really well seen here on the True Color RGB. So the reason why this dust storm was so pronounced is the seasonal wind, the preceding heat wave and drought that created really good environment for strong lifting that is necessary for convection.
So hi everyone from my side as well. So just a little bit of introduction. My name is Dominik Rukavina. I am the EUMeTrain training support officer, and I also do a little bit of satellite visualization stuff here at our service. And I'm actually not a forecaster. I have a master's degree in geological engineering, and in my free time when I'm not in the office, I usually do some type of outdoor activities. So let's get into the topic. And first thing I would like to ask you, what do you think you see here on this FCI True Color RGB? This is from May 18 at 5:50 UTC. And what I mean by what do we see, I mean the aerosol plume over the Mediterranean and over parts of Spain and Northern Africa. So feel free to write in the chat, what do you think this is? There aren't many options. So, okay, I see one comment. Yes, yes, so exactly. It's a smoke. If we go to the dust RGB, we can see that essentially there is no trace of no dust signal, so to speak, neither over the Mediterranean or over the Spain or Northern Africa. And if you go back in time or further in time, you see that really there is no signal whatsoever. So you might think that there is maybe no temperature contrast between the surface and the plume. And in reality, it really is smoke, so not dust. But where does it come from? And to find that out, we have to go to the west, about 7,000 kilometers to the west, to the Canadian province of Manitoba, where there was a wildfire episode or wildfire season started around May 13th and 14th. And here we can see some aerial photos of the fires. Really, it covered the west areas of the wilderness, and we can see the smoke plumes rising into the air. And here on May 13th, on the NOAA WIRS Fires and Thermal Anomalies product with the 375 meter resolution, we can see the fire areas, the fire hotspots, with the most activity being here in the southeastern part of the Manitoba province. But all around, there were some fires in the northern US, in the Ontario province as well here, and the Saskatchewan province as well. And you can see here that really the largest area, so this one here is this area zoomed in. It was about 600 square kilometers, so quite a lot of fire activity. And here on May 14th, from the Terra Modis, same product, different resolution, you can see that some of these hotspots were really extremely hot, giving the fire radiative power of over 2000 megawatts. And we can also have a look at it from the goes east in the fire temperature RGB. So this is May 13th. And as it is developing, you can see the intensity rising in the RGB. And then through the night, the activity was still present, going to May 14th. And here we can see the evolution from May 13, 15 UTC to 00 UTC. really vast amounts of smoke being injected into the troposphere. And here is the image on 13th of May from Sentinel-3. And if we want to look at how it was traveling, we can have a look at the Sentinel-5P TROPOMI UV aerosol index product. It is a good product because it can also be calculated in the presence of clouds. And for a given wavelength pair, our ratio is calculated from top of the atmosphere reflectance and a pre-calculated theoretical reflectance for a Rayleigh scattering only atmosphere. And then the results are a residual value. And if the value is positive, it indicates the presence of a UV absorbing aerosol. And here on this animation, you can see that the fires started here in Manitoba, just a second, right here, and then it travels onwards across the Atlantic to the south and then up to the Mediterranean area. And here, if we overlay the UVA product from TROPOMI with the goes east, we can see clearly that the smokes on the May 13th produced this large aerosol injection into the atmosphere. And the same thing can be seen also on the Suomi aerosol index imagery. So, or the product. So the path is clear. And then it continued on across Turkey and went into Asia after May 19th, May 20th. And here, just a little bit more information. We can see that, so the fires, the hotspots were around here. And essentially there was a jet stream right above where the fires happened, and the jet stream carried the smoke across the Atlantic. And if we look at the geopotential height fields from the 300 hectopascals on May 13th, we can see that it clearly coincides with the path that we saw earlier on the TROPOMI product. And then if we go to May 16, we can see that this low pressure system kind of went a little bit towards east, and it pushed the trajectory of the smoke a little bit further south, and then it went back up through the Mediterranean. And here we can very nicely see on the FCI True Color loop the smoke plume when the sun is low in the east, and then it travels very slowly, but it covers a great area. And so when the sun is now moving towards the west, we again get this scattering effect. Okay, so here's the sun glint, but here is very, very accentuated signal from the smoke. And then here we can see on May 17th, the smoke plume here at 15 UTC is barely visible. And then as the sun goes to the west, when the solar zenith angle gets high, you can get this very, very nice signal of the plume over Europe and over parts of Africa. And then resulting in the image from 18th of May in the morning, when really it looks much thicker than it actually is due to the geometrics, but still a very, very nice depiction of the smoke from Canada. And in the summary, actually, I just wanted to show you one more thing, and that was here. If you really want to play with geometry and use the scattering, so you can, for example, here we are using the MTG True Color, and the sun is in the west. And if you want to, for example, see it on MSG, you can use the IODC, the Indian Ocean mission, with the satellite being further in the east. And obviously you have the very, very noticeable sun glint, but you can clearly depict the aerosol, the smoke plume over the continental parts. So here you get the full benefit of the sun to satellite geometry. And back to the presentation. So a short summary. The True Color RGB, it is really good for dust detection, especially over darker areas like the sea and the ocean. So it is even better for optically thinner aerosols like smoke in comparison to the dust RGB, of course, particularly when the high solar zenith angle is present. Dust RGB is less effective if the plume lacks a specific thermal signature or difference in regards to the surrounding, or if it is less optically thick in the given wavelength, and given that the smoke particles are smaller than dust particles, it is less optically thick in the infrared wavelengths. And of course, we have the me-scattering being the dominant scattering regime with any type of aerosols, and then the forward scattering is enhanced when the sun is low in the east or the west. And as the particles gain size, then the scattering gets more equal, and there is no preferential scattering towards either parts of the spectrum. So yeah, that was it from my side as well, and feel free to ask any questions either to me or Kristina, or give any comments. Both are welcome. Thank you very much.